Okay, so these integrals that we've been doing have been indefinite, no bounds. We just want to know what is the function that if we derive it, we would get the original integrand. Guys, the integrand is this piece right here that I was talking about, has to be written in terms of t in this respect. So you have, oops, I have this in respect to t, means this whole function has to be written in terms of t. That thing that I just highlighted in orange is called the integrand. Okay? The integrand. Kind of picture that right here with radicals like x squared plus 4. Does anyone for bonus points know what this is called? The radicand. Good. It's the radicand. It's the stuff underneath the square root. So the stuff underneath or inside, if you will, over here with calculus, this is called the integrand. Okay? Here we go. I'm going to, and again, there's so many methods that you can do. You have to decide which one works for you. You could distribute, if you wanted, you could distribute the root t to show 3 root t minus what? What would that become? Good. T to the 3 over 2. If you don't know that, you got to retouch a lot of stuff with your algebra 2 right now. Okay? Because this t square rooted is t to the 1/2. And it's t multiplied. We know this is 1. Otherwise, what I hope that you're thinking about is 2 over 2 because of that common denominator. So then you add from what you learned in algebra 2 rules. Okay? Nothing has happened integration-wise, okay? Remember, when you integrate and you actually antiderive, this dt and that symbol right here, this right here and this, they disappear. They go away. I haven't done that process yet. So I still have this, not one integrand, but I have 2 integrands. That's huge what I just said. Over here, I had 1 integrand. And here, it's still 1 complete integrand, but I'm going to say there are 2 pieces to this integrand. Whereas over here, there was only 1. Who can tell me why? Okay, yes, subtraction and multiplication. Here, this subtraction is separating 2 huge islands that there are 2 pieces. What is here that makes this 1 piece? Multiplication. And if you didn't learn that from algebra 2, there it is. That multiplication fuses those 2 monomials to be 1 huge monomial. You with me? Okay. So now, watch the rewrite. For this first one, I'm going to constant multiple rule the 3 out. And I'm going to rewrite this square root of t. And I'm going to bring down the in respect to. Have I, bless you, have I integrated yet? Yes or no? No, I still have not. I'm just rewriting, getting it ready to integrate. Okay? This next step, there's nothing to be pulled out constant multiple rule because the only thing left is a variable. So it will be from 0 to 3 on both of them, just like this. Okay? So what's the antiderivative of t to the 1/2? T to the what? 3/2 divided by 3/2, but I would rather you say multiply by 2/3. And then now we are going to subtract. I'm going to do this all in. I'm going to combine it to be 1 huge piece now because that's the way you're going to ultimately develop it. So minus what? What's the antiderivative? What do I do? T to the 3/2 becomes t to the 5/2 times what? 2/5. What do we call this entire thing that I've just written down right now? What is that called? The antiderivative. This is called the antiderivative. And we're going to evaluate this. I'm not done yet. I got to write something that I forgot. Who can tell me what I forgot to write? The 3, right? The 3. Good mistake. There's no plus c. That's a really good mistake. There's no plus c because it's not indefinite. Indefinite means no bounds, not bounded. This one is bounded between 0 and 3. So there's no extra plus c excess. Okay? You see that I multiplied with 3. I can just cancel these two, can't I? Okay, so let's go ahead and cancel this out and simplify this just to say 2t to the 3 halves minus, and again, there's so many different ways to do this. You develop what's good, quick, and limits errors. Okay? So this is going to be from 0 to 3. How do I express this? I'm going to plug 3 in first. Let me highlight this. I'm going to plug in 3 everywhere where I see a variable of t. And whatever that is, I'm going to subtract everything. So let me put that in green so that you can visually see it, whatever that is. Then I'm going to plug in this 0 everywhere for t. And whatever that is, I'm going to put here. Otherwise, the final position, f of b, minus the initial position, f of a, otherwise known as displacement. So the integral is displacement. Okay? Alright, let's do this together. I'm about to plug in 3 right here for t. What should I do first? Cube it or square root it? It really doesn't matter on this one, right? Because it's not like a number like 4 that I can square root to a nice pretty number. You with me? So it will be 3 to the 3 halves times 2 minus over here. This one's going to be an ugly number. Okay? And can you put the whole thing without simplifying it into your web sign? Yeah. You don't have to simplify and you do not have to combine. So I would just rewrite this whole thing, just put in right there. You with me? And just put the 3 wherever you see t in nice good parentheses. Okay? When I put 0, what does all that equal? 0. Now be careful. If I plug in 0 into the antiderivative, will it always be 0? What do you think? No. You have to verify that it is. Okay? So basically putting 3 in here, the answer is going to be, see, they put this as far as they simplified everything out. You don't have to, okay? You don't have to. You can leave it like that, and on the AP exam, you would still get full credit. Would this be a question that's on your multiple choice that they would expect you to get down to this? No, they're not that crazy with your Algebra 2 skills. Okay? Questions on this one?